Water is our most precious and arguably most undervalued natural resource. Not only is it essential to our existence and all life on this planet, it is vital for food production and economic development. Moreover, water plays the most fundamental of roles in our weather and climate. However, with a growing global population and an increasing demand for modern lifestyles, our water resources are constantly under threat from overuse and pollution. In addition, the effects of increased human activity are changing our climate, which among other issues are thought to be leading to an increased frequency of extreme weather, causing floods, landslides and drought. If we are to secure our future on Earth, the need to understand and monitor our environment has never been more important. The best way to do this on a global scale is from space. To this end, the European Space Agency is developing a fleet of small satellites called Earth Explorers to observe and monitor specific aspects of the Earth system. One such explorer mission is dedicated to advancing our knowledge of the water cycle. The Soil Moisture and Ocean Salinity Mission, or SMOS as it is referred to, will use new technology in space to provide global maps of the moisture in soil and salt in the surface waters of the oceans. These data are urgently needed to understand more about the Earth's finite water resources and indeed whether its cycle between the oceans, the atmosphere and the land is actually speeding up as a result of global warming. The information that SMOS will provide is also needed to contribute to climate, weather and extreme event prediction. Salt in the oceans and water in the soil may seem unconnected, but in fact they are both intrinsically linked to the Earth's water cycle and therefore weather and climate. Soil moisture forms an important component of the terrestrial part of the water cycle, being a key factor controlling the exchange of water and heat energy between the land and the atmosphere through evaporation. Along with temperature, the varying saltiness of the oceans is an important driver in global ocean circulation patterns. This conveyor belt-like circulation is a crucial part of the Earth's heat engine and vital for regulating the weather and climate. Ocean salinity is largely controlled by a balance between evaporation and precipitation, but processes of seawater freezing and melting are responsible for increasing and decreasing the salinity of the polar oceans. It is the cold, dense, salty waters of the Arctic that drive the Gulf Stream, the waters of which are responsible for Europe's mild climate.
Water is the main driver for the exchanges between the atmosphere and the soil, and by such, monitoring these changes help us have a better weather forecast, weather prediction, because this is the goal, or better monitor climate changes. So by being able to measure accurately the water available in the skin of the Earth helps us have a better understanding of the future weather.
I think that one of the importance of a SMOS is that for the first time we'll have a measurement from space that will provide regular information on sea surface salinity. And this is extremely important, especially in regions where salinity has never been measured.
The new SMOS mission will carry state-of-the-art technology in the form of a sophisticated interferometric radiometer called MIRUS. Its large, Y-shaped antenna, which carries no less than 69 separate antenna receivers, detects microwave radiation emitted from the surface of the Earth and translates the data into maps of soil moisture and ocean salinity. This innovative instrument has been developed by EADS CASA in Spain on behalf of ESA. The technology is similar to what radio astronomers use in their Very Large Array, only scaled down. They use a baseline of some 36 kilometers to map the sky, whereas SMOS uses just 8 meters. Just as challenging as the technology is the programmatic setup, where the mission is managed by ESA, but French and Spanish agencies all provide specific contributions to the project. SMOS will launch from the Plesetsk Cosmodrome in northern Russia on a modified Russian intercontinental ballistic missile SS-19 launcher. The payload will be carried on a satellite platform developed by the French space agency CNES and Alcatel Space Industries. The development of the SMOS mission not only deals with the engineering aspects of building a brand new instrument, but also involves long-term groundwork out in the field to test the measuring technique. A number of such field exercises over land and sea have already been carried out and will continue after launch as part of the validation program. The technology that the SMOS mission employs is expected to make a breakthrough in remote sensing techniques, provide much-needed data for understanding the Earth's water cycle, and help with the prediction of weather and long-term climate change. SMOS will be particularly important for helping forecast extreme events such as floods and landslides, therefore giving people time to take the appropriate measures to reduce the devastating effects that these disasters can bring.